For our last section that we are going to look at in this course, we're going to talk about regression lines. We already talked about linear equations on our last video. So today we're going to talk about how can you get the best line of fit for data. How can, if I give you a couple of lines, can you determine which of those two lines would be the better fit? So we're going to do two things today. Try to find the line of better fit if you're given a couple of lines, and then find the line of best fit. Before we even get to that, let's look at some different scatter plots. And the question would be, can you find the line that would correspond to the scatter plots? For instance, here's temperature and the amount of things that you sell depending upon the various temperatures. We can see that there would be a line going out through there. But how do you find that line? And once you find the line, then you can make predictions as to how much you would sell at various temperatures. But how do you find that line? That's what we're going to be doing. Here are some different scatter plots. Obviously, there should be a line going through this one. This one's rough, but you can somewhat see there's negative correlation going on here. As this gets bigger, this gets smaller. Okay, this is positive correlation. Here, you cannot do a line, okay, because there's no correlation whatsoever. Here, there would be one positive correlation here, negative there. There's not one line that truly fits that. So we're hunting the line of better fit and the line of best fit. All right, so here we have some data. I plotted the 5 data points here. We have 2 lines. Y equals x is this blue line. You can see that going up through there. And y equals 2/3 x plus 1 1/3 is this line. So we have 2 lines, this one and this one. We want to find which of those 2 lines is the line of better fit. Okay, so you make a chart with headings of x, y, y hat, e, and e squared. Let's do that. So I have x, y, y hat, e, and e squared. First line is y equals x. So my data, put the data in. So I've got 1 and 2, 2 and 3, 3 and 2, 4 and 3, 5 and 6. Y hat is simply the y value you get when you put the x value in. So this one ought to be easy. When I put 1 in, I get 1 out. Put 2 in, I get 2 out, and so on. Okay, now let's find the error between what the data value really is and what the equation tells me it would be. There's an error there of 1, error of 1. This is technically an error of -1, but because you're going to square it, you're going to get a positive anyway. 1 and 1 squaring is all 1s, and I get a total error of 5. Okay? That's the amount of error. Now, I wonder how much error this line will give me. If it's less, that would be the line of better fit. So we can let all the data here, and let's just get rid of this part. And now let's do it again for this line. All right, so I'm going to be putting 1 into this equation to get y hat. And we want to be careful of our fractions here. When you put 1 in, I get 2/3 plus 1 1/3 is just 2. Putting 2 in, 2 times 2/3 is 4/3. 4/3 is 1 1/3. 1 1/3 plus 1 1/3 is 2 2/3. Put 3 in, 3 times 2/3 is 6/3. 6/3 is 2. 2 plus 1 1/3 is 3 1/3. Let me double check that. Put 3 in, 3 times 2/3 is 6/3, or 2. 2 plus 1 1/3 should be 3 1/3. Put 4 in. 8/3 is 2 2/3 plus 1 1/3 should be 4. And putting 5 in, 10/3 is 3 1/3 plus 1 1/3 should be 4 2/3, I think. Let me double check that. And I should get, let's find our error and our error squared. Okay, so the error here is 0. Error here is 1/3. Error here is 1 1/3. Error here is 1. Error here is 1 1/3. Error squared, 0. 1/3 times 1/3 is 1/9, which is 0.11. 1 1/3 squared. So we have, and I get 1.78. 1 squared is 1. 1 1/3 again is 1.78. You add all these up, I get a total error of 4.67. So the equation y equals 2/3 x plus 1 1/3 has an error of 4.67. The second one, this one, has less error than the first one, so it is the line of better fit out of the 2 lines that I gave you. Now the question is that necessarily the line of absolute best fit? Maybe there's a line out there someplace that would give you a less error than this, and it would be the line of absolute best fit. Okay. And this just more or less retraces what I just said. We found the line of better fit. It's called the least squares criterion because we wanted the least amount of squared area. Least squares criterion. The line is called the regression line or the regression equation. This is the regression line or equation out of the 2 that I've given you. And notice once again, we have found simply the better line out of the 2. We have not found the line of best fit. And now it's playing games with me again. Oh, yes. Okay. So let's get the line of best fit. The line of best fit, we have to make a new chart. Okay? We're going to make a new chart with headings of x, y, x times y, and x squared. And now, once again, we need the data. I'm going to have to back up and get my data. Once again, is 1 and 2, 2 and 3, 3 and 2, 4 and 3, 5 and 6. Okay? All right. Now, you simply multiply x times y is 2, 6, 6, 12, 30. Square x, 1, 4, 9, 16, 25. And now we need the summations of all of these. So we have to add these up. 9, 12, 15, 9, 11, 16. Add these up. 8 and 6 is 14. And 14 and 12 is 26. And 30 is 56. Double check that. 42. And 8 is 56. Yep. 25 and 25 makes 55. Double check that. 16 and 4 is 20, 9 and 1 is 10, that's 30, and 25 is 55. Looking good. All right, to get the line of best fit. And by the way, you do not have to memorize these. I will have these for you. So the slope is equal to the summation of the xy's. Summation of the xy's, I'll put it up here, is 56 minus the summation of the x times the summation of the y. So I got to multiply 15 times 16, which is 240. 240 for this, divided by the amount of data is 5. Then it's this whole thing right here is divided by this one. So I need to take this one divided by this next one, which is the summation of the x squareds is 55. 55. Now look, this is the summation of the x's squared. This one is different from this one. So I've got to take the summation of the x's, 15, square it is 225, and divide by 5. Okay? 240 divided by 5 is 48. 56 minus 48 is 8. 225 divided by 5 is 45. 55 minus 45 is 10. This was 8 divided by 10. 8/10 or 0.8. Okay? That's just the slope. Now, B naught, your author likes to use B1 and B naught instead of, why can't he use M and B? Y equals MX plus B. M slope B, but anyway. He uses B naught for the y-intercept. So we have the summation of the y's. I'll try to squeeze it in here someplace. The summation of the y's is 16 minus the slope, 0.8, times the summation of the x's, 15. Okay, and that's all divided by 5. All right, so I have 0.8 times 15, I think, is 12. 16 minus 12 is 4. 4 divided by 5, that's odd. 0.8 again. So I have the line of absolute best fit is y equals 0.8x plus 0.8. Okay? This is the absolute line of better fit. If you would go back and make a chart like we did before, all right, you would get a smaller amount of error even than this one, because there is no line that is a better fit than that particular one. Okay? All right, so let's. I've got another one I want to walk through with you so you know how to do this. Once again, remember, those complicated formulas you do not have to memorize. All right, now here, what we have, similar situation. I've got 4 items of data. All right, let's go over here. Over here, I have the data, 1 and 0. All right, so there's a data value right there. And that marker is of no value. Okay, so 1 and 0 is a data item there. Okay, 2, -1 is a data item there. 3, 4. 3, 4 is here. And the last one is 4, 5, which is up here. Okay, so there are your 4 items of data. Now, the lines may be a little tricky to see, so I'm going to try to highlight those. Here is one of the lines coming down through like this, okay? Here's another one that is coming down through like this. And the last one coming down through like this. All right? Hope that didn't make that too complicated. We want to find which of these 3 would be the line of best fit. Which line out of the 3? Out of the 3 that I've given you. Okay, we need the equations of these 3 lines. All right, so let's get the equations of these lines. This one is easy. You can see it hits at -2 and the slope is up 2/1. So that line is y equals 2x minus 2. Okay? This one looks like it hits at -5 and the slope is up 3/1. So it's y equals 3x minus 5. I hope that you can read that. Yep, looking good. Now, how about the last one? This line over here, I know the slope is up 5/1. I'm not exactly sure where it hits the y-axis. So I know it's slope of 5. And let's put a point in. The point here is, how about 3, 4? So if I put 3 here and 4 here, 15 subtract off of 4 is a -11. All right, so there I have 3 lines, and I want to determine out of those 3 lines, which would be the better of the 3 lines, okay? So we do what we did in the last one. We're going to make the x, y, y hat, error, and error squared. Data, 1, 0, 2, -1, 3, 4, 4, 5. Y hat, we'll do this first one. When you put the x value in, what the y value of the equation gives you is your y hat. So I need to put the x values in here for x. So I put 1 in here, and I get 0. I put 2 in here, and I get 2. I put 3 in here, I get 4. I put 4 in here, I get 6. Okay? Error is, subtract these, the error is 0. The difference here is, from here to here is 3. Difference here is 0. Error here is 1. Square, 0, 9, 0, 1. Total error for this one is 10. Okay? Total error of that one. All right. How do we fare with the second one? So I need to get rid of just these columns and do it again for the second one. All right. So putting x in, I get 3 minus 5 is -2. 6 minus 5 is 1. 9 minus 5 is 4. 12 minus 5 is 7. Error is 2, 2, 0, and 2. Or square, 4, 4, 0, and 4. Total amount of error for the second one is 12. Okay? And 1 to go. So I will get rid of these 3 again. Okay, and I put 1 into this last equation. I get, -6. I get -1. I get 4. And I get 9. All right, which I think is right. Error is 6. 0, 0, 4 is 36, 0, 0, 16, 52. Wow. Okay. So out of these 3 lines, y equals 2x minus 2 has the smallest amount of error of 10. This line right here, y equals 2x minus 2, which goes through 2 of the data values, 2x minus 2 has the least amount of error out of those 3 lines. Now, which line would be the line of absolute best fit? Okay? The line of absolute best fit, we need a different chart. So let's get rid of this. And we need, here's our data. We need xy, and we need x squared. Okay? So We have x times y would be 0, -2, 12, 20. X squared, 1, 4, 9, 16, add them all up, is 7, 10. This one is, add them up, is 8. This one would be 30. And this one, 2010, is 30. Okay? All right, so let's determine the line of absolute best fit. We need our formulas once again. There are the formulas. Where are the formulas? There they are. Okay, so there are the formulas. So let's figure out the slope first by using this top formula. The summation of the xy's is 30. Let's see where I can squeeze that in. I'll try to get it in here. Is 30 minus the summation of the x's times the summation of the y's. 8 times 10 is 80, divided by 4. Okay? 4 items of data. Then divided by, over here, we have the summation of the x squareds, which is 30, minus the summation of the x's squared. 10 squared is 100, but divided by 4 is 25. So 80 divided by 4 is 20, 30 minus 20 is 10, 10, and 10 divided by 5 is simply 2. So we know the slope is 2. Now, what's going to be the y-intercept? Summation of the y's is 8 minus the slope of 2 times the summation of the x's is 10, and then it is all divided by 4. All right, so 8 minus 20 is -12, divided by 4 is -3, and the line of absolute best fit for that data would be y equals 2x minus 3. If we go back to that screen, y equals 2x minus 3. It's getting rather cluttered, but y equals 2x minus 3 would hit here at -3. It would be up 2 and over 1. It would be a line that kind of goes in between this data, and that is the line of absolute best fit. You cannot find a better line of fit. And that pretty much wraps up our course. The homework will be a variety of some different kinds of problems. This will be your last homework assignment in here. And I've got the text problems down at the bottom for you to practice lines of better and best fit.